Today, more than 400 million people suffer from diabetes in the world. Only in Europe, almost 10% of the population are affected by this disease. A lot of cases of diabetes are of the type 2, the type that is related with behavioral factor, which means that it is preventable through interventions such as healthier dieting and increased physical activity. Hello, my name is Jorge Saldivar. I am a postdoctoral researcher at the BSc, and before landing in Barcelona, I participate in the Data Science for Social Good Fellowship at the University of Chicago, where I work in a prevention effort that uses machine learning to promote earlier and more efficient intervention for type 2 diabetes. The work was done in the United States and in partnership with Alliance Chicago, a non-profit network of more than 40 community health centers that are serving the least resource members of their communities. So let's consider a patient who walks into one of the Alliance clinic. Say this patient is 23 years old, obese, has a family history of diabetes and hypertension. In reality, this person is in a pretty high risk of developing type 2 diabetes in the future. So what a clinician can do to identify her risk during the visit? Current screening guidelines for type 2 diabetes are mandated by the United States federal government. And these screening guidelines are simple checklists of two things: whether or not the person at the moment of the visit is between 40 and 70 years old, and whether or not the person BMI at the moment of the visit is greater than or equal to 25. So you may be wondering how well the screening guidelines perform. This is when Alliance came to us, noticing that in their patient population, about half of the people who were diagnosed with type 2 diabetes did not meet the screening guideline at the moment of the diagnosis. The person that I introduced before would have fallen out of the screening guideline and be part of this 50%. So the goal of this project was to transcend the screening guideline and give providers a more personalized tool that they can use to perform screening in their patient by building a predictive model of an individual risk of developing type 2 diabetes in the future. Alliance provides us with a wealth of information. From their de-identified electronic health records, we receive data on over 1 million patients from 24 community health centers. This amounts to 8 million visits dating all the way back from 2006 up to 2018. We identify cases of type 2 diabetes by looking at the following information in the patient record. If the person had a diagnosis with the ICD code of diabetes, or if the person had 2A1C test, which is a blood test, greater than 6.4, or if the person had a prescription of metformin, which is a medication used in cases of type 2 diabetes. After identifying cases of type 2 diabetes, we define when our intervention will happen, and we decide to compute the person's risk of developing diabetes at the moment of the visit. So the rows in the data set we use to train and test our models are patient visits. Then we label each of these rows to indicate whether at a given visit the person will develop diabetes in the next 3 years. So a given visit gets a true label if the diagnosis happened within the next 3 years from the moment of the visit, and this 3-year window is included in our data. So you may be wondering, why 3 years? From conversation with doctors, we learned that any time windows of less than 1 year does not provide enough time for an effective intervention. And in any time window longer than 5 years, it's hard to identify risk. So in agreement with them, we decide to go with this 3 years time window. After several conversations with our partners, we came up with the following list of features, which were used to train and test our models. Some of these features were directly obtained from the raw data, while others were computed using aggregation functions. Now, let me briefly talk about some aspect of our technical solution without entering in many details. We implement our solution as a pipeline that in the first part takes the external and raw data provided by Alliance and after several cleaning and pre-processing tasks, it integrates this data into a new clean database schema. Then rows and labels are generated, as I explained before, and also at this point of the pipeline, futures are computed. The second big component of our solution is a pretty common machine learning workflow that, among other things, perform model training, metric computation, and model evaluation. So let's go back to the screening guideline that I presented before and use them as the baseline to compare the results of our solution. So in our patient population, the screening guideline will recommend screening in 20% of the visit. At that screening rate, they will be able to identify 53% of cases of people who will go on developing type 2 diabetes in the next 3 years. The model we built shows a 10% point increase at the same screening rate. And what is interesting about the model we built is that we can actually have the same coverage at the screening guideline by screening less people. Or even better, if we screen in just 5% more of the visit, we can pick up to almost 75% of the cases. So let's consider again the patient that I present at the beginning of the presentation, that the person that will have missed by the screening guideline. Now, with the model we built, we can compute her risk of developing type 2 diabetes in the next 3 years. And where this model is handed directly into the hand of clinician who can use to perform personalized screening for their patient. Connect patient at a higher risk with intervention and services to lower the risk, and ultimately prevent more people from being diagnosed with type 2 diabetes. And in this particular case, keep Alliance population healthier and living longer. Thank you so much for being here today. It was a pleasure talking to you.